Okay, so now if you look at the problem 15, right? So this is chapter 5. Chapter 5, if you look at the chapter 5 hash functions, right? At the end of the chapter 5, there's exercise problem. And by the way, I'm recording this. If you look at the problem 15, right? Does MAC works as a HMAC? That is, does a MAC satisfy the same properties that HMAC satisfied? Okay. And then let's look at the problem 16. The problem 15 and 16, it can be combined. And both problems can be combined into one. Suppose that you know that HMAC is X and the key is K, but you don't know the message M. Can you construct a message M prime that has its HMAC equal to X using the key K, right? So given an algorithm for constructing such a message, if not, why not? Note that we are assuming that you know the key and then same key used for both HMAC computation. It may be instructive to compare this problem to problem 43 of the chapter 3. Okay, now, so let's take a look at this problem. Okay, first, okay, oh, you know what? I need to show the, hold on. I need to show the lecture note. Hold on, where is my lecture? The lecture slide. Hold on. Okay, so now, so there is a, okay, so it's the, you can be confused because when they say the MAC, right? They are talking about MAC that we learned in chapter 3. Okay? In the chapter 3, right? We learned about the MAC, right? Okay, yeah. So this is what they're talking about, the MAC. But the paper, right? Where is the paper? Okay, so fine, no problem. Okay, so if you read this paper, right, sometimes they're talking about the MAC, right? So I know this could be confusing because, MAC, it's what the MAC means, the message authentication code. Right? So that's the definition of the MAC, message authentication code, right? And so, the HMAC, okay? So, okay, let me just write this down because I don't want you to confuse, okay? So you can think this way, really. In general, right? It's like, here's the MAC, right? Message authentication code. So this message, authentication code, right? Okay, so this is basically you can think this as a like tag. Okay, so you have a message, right? And then you usually put the tag. And that is called a MAC. Okay, in general sense. Okay, and so in the MAC, of course, there's a couple of ways. We have HMAC, right? Or maybe the hash itself, just regular hash function. It could be the code, right? Okay, you know what? Maybe the hash is not okay. So the hash. The regular hash functions, same thing, right? The hash you can also consider as a tag because you have a message and then you have a tag, right? So basically, this is hash value of this message, right? However, when you say, okay, the key word here is authentication, right? So the MAC, right? So MAC means authentication, right? So let's say this is a MAC, and then MAC is also a tag, just like what? The hash is also a tag, right? And then within the HMAC, there are many different MAC, right? HMAC, or what? As shown in this paper, is called what? The CBC MAC. Okay. So it could be HMAC. So HMAC use the hash functions, right? But there's another type of MAC is called what? What is it? CBC, right? CBC MAC. This CBC MAC is basically this. The CBC MAC is basically this. That's something that we learn in our basically in this book. It does not really call it a CBC MAC, right? But I think in this textbook, when they say MAC, it really means CBC MAC. Okay, so I know that. So please don't be confused. Okay, but in general, right? In general, and this is the. Okay, where's my note? Okay, so what it really means is this. So this is the MAC, right? In the MAC, there's two different. Mainly, there are. You can use the HMAC to produce the MAC value, which is a tag, right? This is code, some value based on this message. And the reason that they put the authentication is that what? They use a shared key K. And that's why they put the word authentications. Okay? And for the CBC MAC, same thing. The CBC MAC is what? Is a message authentication code, right? And then it's also the tag, right? But difference between what? So difference between, okay, there's HMAC and then there are CBC MAC, right? But in our text, they don't really use the CBC MAC. They're just using the word MAC. But in our text, when they are using the MAC, right? Please know that this is what? This is a CBC based MAC. Okay. But of course, there are similarity and difference, right? Obviously, what? The similarity is what? Both of them is what? Both of them is the message authentication code, right? And then of course they are both tag, right? What is the difference? The difference is obvious, right? HMAC, they are using what? Hash functions. So basically what? For the HMAC, by the way, this is conceptually, this is a hash functions. I mean, it's more than its hash functions. It's a more complicated, but roughly, right? Conceptually, you have hash functions, and then you have message M, and then you have shared key K, and then it generates what? HMAC value. Or sometimes it's called MAC value, or sometimes it's called HMAC value, right? But CBC MAC, they're using what? They're using the CBC. They're using what? They're using this CBC scheme, right? By the way, the CBC means the CBC mode. It's like that's the encryption mode, like symmetric, right? This is like symmetric encryption mode, the CBC, right? So this is a CBC mode, right? Okay, so that's the difference. The one for the difference is this case they're using hash functions, right? hash function with a key to generate HMAC value. And for the CBC MAC, they're using what symmetric key encryption algorithm called CBC, right? And then of course it's symmetric key, so there you have to use a shared key, right? So for the CBC, they're using a shared key, right? And then what? They're using symmetric key encryption algorithm, right? Called what? CBC. Okay, so that's a difference actually. Okay, I don't want you to confuse. Okay, now, so if I just review the CBC a little bit, right? I mean, for the integrity, like let's look at the MAC. Basically, you have a IV, which is just random value, and then you have a P0, P1, P2, P3, right? Let's say this one has only P2. Like, let's say this is example. So you have a plain text. By the way, this is a review. And then let's say this is M, right? The M, you have a 3 chunk, P0, P1, P2. And then using the CVC mode, I'm gonna skip this, like, right? So you can take a look at how you can compute the C0. But anyway, from P0, right? You can compute the C0 ciphertext. Then from P1, actually, the P1, P1 and C0 using this, and you can compute the C1, right? And then using the C1 and P2, you create C2, right? Ciphertext 2, right? And basically, this value, I believe that this is the, yeah. So basically, this is going to be your MAC value, message authentication code. Okay. So basically, so that means, for both both HMAC and CBC MAC, right? The idea is the same, right? Idea is when you have a Alice, and then when you have a Bob, when the Alice sends the message M, right? So you also need to send a tag, right? You need to send a tag. And in our case, it's MAC value. In case of what? In case of, if you use the HMAC, your tag value, right? So basically, you have a message M, and then you need to have a tag, right? And then in case of you use the HMAC, it's really a hash value and the message and then the key. And then by the way, the key is a shared key, right? The key shared by both Alice and Bob, right? And if you're using the CBC MAC, it's really what? It's really C2, right? So that's a tag code, message authentication code. So this is the MAC, right? And this is also the MAC, right? So I'll call this, sometimes I can call it HMAC, and then I'll say CBC MAC to differentiate these two. But the idea is the same, okay? Okay, by the way, if Alice, okay, if the Alice sends a message M, oops, this is too thick. If the Alice sends a message M, right? And then it just sends H of M, right? So what is the problem with this? Anyone? So this is just regular hash. So this is like a regular message digest. It's still, yes, it still is a tag, right? But it's not a MAC, right? Just hash value. So what is the problem? The problem is, you know that it's obviously this is like the real problem is when the Bob received this M and HM, right? Bob does not, right? Does not know what? Where, basically, if I just use this one word, what? Does not know what? Oops. Does not know the origin, right? Origin of the message. So is this really from Alice? Or maybe this is from the Trudy? Is it really from her? Is it really from the Trudy or is it from Alice? I have no idea, right? Because what the Trudy can do it is like what the man in the middle, like Trudy, right? What she can do it is, hey, Bob, I'm Alice. Okay, I'm Alice. And then here's my message, M prime, from H of M prime. Of course, this M prime is I hate you. And original message she's preparing is I love you, right? And when the Bob received this M prime, right? M prime and H of M prime. You know, of course, Bob goes through like a hash this is M prime, right? And compare these two. And then, yes, no problem. But the problem is, the problem Bob has is like, is this M and H of M, this tag, is really, is this message is really from Alice or someone else? I have no idea, right? So what is this problem? So Bob has the what? Authentication issue. And so to resolve this issue, we can use what? We can use HMAC, right? And that's why it says authentications. So if you use HMAC or the CBCMAC, and of course the problems goes away, right? The Bob now knows that this message is really from Alice. Because, I mean, to be precisely, Bob knows that this message is from someone who knows the shared key, right? So that's why. So it's resolved the authentication issue. So any question? So that's the MAC, right? That's the HMAC and CBC MAC. To just solve one problem, I know that I have to tell you a lot of things, right? Just to solve one small problem. Okay. So where's the problem? Okay. So now you know. So now get back to problem 15. I spent about 15 minutes just to not even talk about the problem, just the background, right? So let's look at the problem 15. So does HMAC works as, the MAC works as a HMAC. So actually the problem 15 is really ask you, when they say MAC, what the author meant is what? CBC MAC. Okay? That we learned chapter 3. So the MAC work as a HMAC. Yes. Right? Because both of them will achieve integrity, right? And what else? It achieves what? Any?
Data authentication?
Yes. Data authentications. So both of them, yes, they work like in a similar way. Although not many security protocol use CBC MAC. Now it's most of the modern security protocols they use HMAC. Okay. Now, does MAC so CBC MAC satisfy the same properties that HMAC satisfy? Yes. And specifically what property? Integrity and what? Authentication. Right? So now let's look at the problem 16. Suppose that you know the output of the HMAC is X and then key is a K, but you do not know the message M. Can you construct a message M prime that has its MAC equal to X using the key K, right? Okay. So let's take a look at this problem, problem 16. So you are supposed to problem 15 and then problem 16. Suppose that the output of HMAC is X, right? So conceptually, I know that it's more complicated. So if you read the paper, you know how HMAC is constructed. But just for the conceptual view, you know, like message M, right? And then shared key K, right? And this is HMAC functions. And then you got HMAC value, right? So MAC value actually. I just put H to distinguish from the MAC value generated by CBC MAC. Okay? But it's a MAC value, but I just put the H, right? But anyway, they said the output of HMAC is, they think that this is X. Okay? And then key is a K. So can you construct a message M prime that has its MAC value equal to X using the K? But you don't know the message M. Okay. So what will happen is, you know K, and then you know X. So you know K and you know X, and can you construct the M? So can you construct the M? So answer is no. I mean, assuming that it's a one way, it's like, you know, but I don't want to say it's like a no, but extremely difficult, right? I mean, depends on like, I think it depends on the length of your hash value, right? Assuming that it's really safe, it's like assuming that it's really long, right? This X is like, it's like what? 240 bits, right? So it's really long, then it's impossible to construct M, right? It's one way, right? It's a one-way safe. Okay, so now, but what about the CBC MAC? Okay, so go to chapter 3, problem 43, right? Oops. Get it. Okay, so I'm just what is this?
You have to check out the ebook, Dr. Sa.
Check out? I hate this. Oh, okay, good. Chapter 3. Okay, so the chapter 3, and if you look at the end of the chapter 3, the problems, and if you look at the last problem, by the way, you don't have to do the last problem of the chapter 3. I'm just showing you the concept and why people are not using the CBC MAC. Why they rather use HMAC. I mean, these days, right? Okay, so same thing. Suppose that you know the MAC, right? So, you know, both for the MAC, CBC MAC and HMAC, the idea is the same, right? Basically, this is the HMAC, right? And even for the CBC MAC, it's so basically this is a black box, right? So this is black box, and then black box takes the message M and then K, right? And then generates the X. And the same thing. So this is a CBC MAC. And then this black box using the CBC symmetric encryption algorithms, right? Okay, so, but this is something that I want you to know. Based on if you look at the lecture note, right? Basically, what that means is from the, if you know the P0, and then if you know the K, right? And then, assuming that you know the IV, well, maybe this is something that you can easily find out. But anyway, then you can guess C0. Okay, so this is not really one way, right? Okay, so for example, right? Okay, so if you use a CVC node, there are some equations like this is like a reverse thing, right? So like for example, like this is like a, by the way, this is like a CVC, right? I mean the PN1, right, is equal to, D means the descriptions, right? You descript, let's say you have a MAC value, right? You know that this MAC value, you know that its MAC value is from what? MAC values is from the C2, right? The last one. So basically, you know, this, even though I said MAC value, this is really from really like C2, right? And then if you use the, if you use the MAC value, and then if you use the shared key, and then you do the XOR with the, let's see. Hold on. C. Okay, you know what? Okay, so if the Alice sends, okay, if the Alice sends, when the Alice sends this message, right? She sends P0, P1, and P2, right? And then some MAC value, right? So basically the equation is Pn2 is equal to descriptions, and if you know the MAC value is from this tag, and then you use the shared key, and then using XOR and Cn2. So basically the last value of the, because assuming that the receiver also knows how to encrypt this P2, right? But anyway, so idea is this. Idea is from using this equation, they can, the receiver, right? In this case is Bob, is able to come up with the plain text. But not all of them, but some of them, okay? So I don't, okay. So basically, I think at least, right? At least receiver can easily compute the P2, but not all of them, right? But at least P2 immediately. But anyway, so in terms of the property, right? In terms of the property, both are really same, right? Both of them is kind of achieve what? Integrity and authentication, right? But there's a subtle difference, right? One uses hash functions and the other uses CVC, right? And I think because of this, now it's HMAC. It's more popular when you need applications which need to have, which need to satisfy integrity and authentication. Okay. Okay, so that's like a problem 16. Okay, so that's a problem 16, right? Okay, and there's one more problem I'm almost done. Oh, it's 9:30 already. Oh, I thought that I can finish this really early, but okay. But there's one more problem. Is that chapter 5? Or chapter 4? Oh, not the advance. Chapter 6. Okay, now I want to do this problem, problem 17. Okay, problem 17 is very interesting to think about. The problem 17, basically you have to read section 5.8.1, right? And I want you to have, when you have a meeting, right, you're a group member, I want you to discuss about this problem, 5.8.1, okay? But let's just briefly talk about 5.8.1, okay? Okay, online bid. So I want you to kind of read this problem, right? And then think about this case. But roughly what that problem is that suppose an item for the sale online and Alice and Bob and Charlie all wants to place bid, right? And the idea here is that these are supposed to be sealed bid. That is, each bidder gets one chance to submit a secret bid, and only after all bids has been received are the bids revealed. As usual, the highest bidder wins, right? Alice and Bob, Charlie don't necessarily trust each other, and they definitely don't trust the online service that accepts their bid. In particular, each bidder is understandably concerned that the online service might reveal their bid to the other bidders, right? So either intentionally or accidentally. For example, Alice placed a bid of $10 and the Bob bid $12, right? And if Charlie is able to discover the value of these bids prior to placing his bid, he could bid $12, right? $12.01. And then, Charlie can win, right? So the point here is that nobody wants to be the first or maybe the second to the second place to place their bid, right? Since there might be advantage to bidding later. Okay. So basically, the first scheme they come up with is like use hash functions, right? So what they're trying to do is for the Alice, right? Alice is going to hash $10, and then the Bob is going to hash, let's say $13, right? And then Charlie, his bid price is, let's say $9, right? Let's say this is like Charlie. So this is a hash by Alice. This is a hash by Bob, and this hash value by Charlie, right? And instead of submitting this value, right, they submit what? They submit the hash value to the service. Okay? So do you think this is really like a safe way to submit their bid? And do you think this is fair, right? And think about this problem. And if you look at the problem 17, there's A, B, and C, and D. Okay? So there are 3 problems you have to do for the chapter 5. Okay? Let's see. Okay, so I'm done. So any questions about chapter 5? There are 3 problems. Okay, so let me stop. I'd like to end my lecture here. I'm going to stop recording.